Well, hello everyone, and welcome back to F.O.A Maths. It's been a little while. I took some time off just to work on other things, but I hope you've all been doing well, and we're going to get back on this learning train. So last couple videos, we've done some neat applications, and I originally was going to do one more application video, but I feel that it might be a little more appropriate to postpone that to a little later on in this series, and then we're going to come back to it. So I'm not scrapping it, we will be doing it, and it will be amazing, but until then, we're going to get back into doing some lectures, but not long after this, we're going to have some more interesting application videos coming up, so I hope you're looking forward to that. But math is also really cool without the applications, and that's something that I think the more you study it, the more you're going to come to realize that math is beautiful in and of itself and doesn't necessarily need the applications. But we are still going to go into the applications because those are really freaking cool too. But today, we're going to discuss coprimes. Alright, so the idea of coprimes is basically it's a property that two numbers have relative to each other. So let me give you an example. Let's say I take the number 9, and I take the number 4. Okay, I can write out their prime factorizations. 9 is going to be 3 times 3, and 4 is going to be 2 times 2, right? These are both prime numbers, and it's the unique combination of prime numbers that make up these two numbers. But what do we notice about 4 and 9? Their prime factorizations are completely mutually exclusive. What does this mean? It means that 4's prime factorization has nothing in common with 9's prime factorization. So basically, they have no factors in common. Remember when we were looking at common factors, we were basically finding their common prime factors? Since they have none, they have no factors in common, except for 1. So we see here that the greatest common factor of 4 and 9 is going to be 1. And the lowest common multiple of 4 and 9, well, that means we have to take all 4's prime factors, all of 9's prime factors, and multiply them. But then since they have nothing in common, we just actually have to multiply them all out, which is going to be 4 times 9, 36. So basically we get the smallest possible greatest common factor, and we get the biggest possible lowest common multiple. And that's from the fact that these have nothing in common. They have no common prime factors. So these numbers are what are called coprimes. So two numbers are coprime if they have no common prime factors. So two numbers are called coprime, or sometimes you'll hear them referred to as mutually prime or relatively prime. It's all the same thing though. Coprime I think is the most common one. I think it also sounds the coolest, coprime, you know. But two numbers are called coprime if their only common factor is 1. But that's the same thing as just saying if they have no common prime factors. And the reason it's the same thing is we saw that, okay, all the factors of a number could be determined by its prime factors, right? We know that 6 is a factor of 24, since 24 has the prime factors of 2 and 3, and that 2 and 3 multiply to become a 6, right? So we were able to use the prime factorization in order to find all the factors of a number. So basically having no common prime factors means that these numbers are going to have no common factors whatsoever except 1. So that means their greatest common factor will have to be 1. All right, so that's literally all the concept of a coprime is. For example, our 14 and 27 coprime. Okay, so all we have to do is we find their prime factorizations. So 14 is 2 times 7. And 27 is 3 times 3 times 3, or 3 cubed. Neither of these have any common prime factors, right? 27's prime factors are all 3's, and 14 has no 3's. So they are coprime because they have no common prime factors, and thus have no common factors besides 1. So yes, they are coprime. How about 15 and 78? Are they coprime? All right, so let's prime factorize these. So 15 is 3 times 5. 78 may be a little trickier to do. All right, 78 is 2 times 3 times 13. So we see, are these coprime? They aren't coprime because they have a common factor of a 3, right? So that means that their only common factor isn't 1, it's also 3. And if we use this condition, they have no common prime factors, well, we see they have a common prime factor, right? So 15 and 78 are not coprime. So this is all that it means to be coprime or mutually prime or relatively prime. It's just a name that we're giving to this concept that these two numbers basically don't have much in common besides 1. And we're going to see that these have really interesting properties both in mathematical concepts as well as in applications. So that's pretty much the concept for today. I'm going to show you two kind of more mathematical applications of coprimes today. And then afterwards, we're going to do a practice video and then a couple of application videos, and we'll be on our way. So we'll call this property 1. So if I take two coprime numbers, that means their only common factor is going to be 1. So the greatest common factor of two coprimes is always 1. It doesn't matter what numbers we choose, as long as they're coprime, they're guaranteed to have a greatest common factor of 1, since that's their only common factor, and we know that since that's the definition of being coprime. Alright, so for example, we saw earlier that 4 and 9 were coprime, so the greatest common factor of 4 and 9 has to be 1. We don't even have to check. If we already know that 4 and 9 are coprime, then we just immediately can say their greatest common factor is 1 without having to actually go through their prime factorizations. So that's the first property. So the second property is about the lowest common multiple of two coprimes, and I kind of very briefly mentioned it earlier, I believe, but can you figure out what the lowest common multiple of two coprimes is going to be? It's going to be always their product. Always their product. So why is this the case? Well, the lowest common multiple is generated by multiplying all the prime factors together such that, we remove any repeats. But since these two numbers are coprime, they have no common factors besides 1, which means they have no common prime factors, which means that when we write out the multiplication of their prime factors, all of them are going to have to be included. So for example, in 4 and 9, right, we knew that 4 was 2 times 2, and we knew that 9 was 3 times 3. And when we write their lowest common multiple, that's going to be 2 times 2 times 3 times 3. There's no repeating here, so 4's prime factors are never going to cover 9's, and 9's prime factors are never going to common 4's, because they are coprime numbers. So to get the lowest common multiple of 4 and 9, what we end up doing is we have to write 4's prime factors, and we have to write 9's prime factors. But that ends up just us doing 2 times 2, which is 4, and 3 times 3, which is 9, or basically doing the entirety of the numbers that we're finding the lowest common multiple of and multiplying them by each other. So that's their product. So the lowest common multiple of two coprimes is always their product. So an earlier example we did 14 and 27. We found that they are coprime. So we know then that the lowest common multiple of 14 and 27, without actually having to go back and check what their prime factorizations are, we know that their lowest common multiple is just going to have to be 14 times 27. Alright, so we should get 378 from that. So since we know 14 and 27 are coprime, by this property 2 here, we're getting that their lowest common multiple always is just going to be their product, 14 times 27. So that's going to cover it for today's episode. We kind of got introduced to what coprimes are. It's a pretty simple concept. It's just kind of another sort of idea based off of what we already know with prime factorizations. But there's a lot of really cool ideas that come from coprimes, and we're going to be exploring some of them in the next few videos. So I will see you in the next practice video where we're going to do some gnarly problems with coprimes. I'm looking forward to it. I'm sure you are as well, my loyal fans. So until next time, have a good one, stay groovy, and I'll see you in that next video.